I'm going to talk about phase shift oscillator. To make a phase shift oscillator, we need an amplifier with 180 degree phase shift. Suppose this is an amplifier with a phase shift of 180 degree and its gain say AV, and it has two input and this two line for output. After that, we need a positive feedback loop with 180 degree as well. Suppose this is the positive feedback loop. The just output is just feeding back to the input. This positive feedback loop also has 180 degree phase shift. This loop only take in one small fraction of output voltage, and this output voltage going to the input of the amplifier as a feedback. Suppose the small fraction of this output is beta. So the output will be beta V out. I'm mentioning this is V out from the amplifier, this is V in for this amplifier, and then when I'm adding this positive loop to this amplifier, suppose here the input is V in prime. If you are able to make a circuit just like this, one amplifier with 180 degree phase shift and one positive feedback loop with 180 degree phase shift as well, and then you will get a oscillation, sine wave oscillation just like this. Suppose the input signal is just like this, the first input signal. When this is passing with this amplifier with 180 degree phase shift, the signal will be converted as like this, because it's completely 180 degree phase shift. That's why it is reversed. And when this signal is again passing with this positive feedback loop, it will convert it again just like this input one. So when this converted positive feedback loop signal is just coming with the phase shift to the amplifier's input, that time the input signal will be reinforced a little bit. This signal will push to the original signal and then make a little bit powerful and fit to the amplifier. And when this procedure will be happening again and again, once a time with little disturbance happening in the input like this whole circuit will start the oscillation by itself, and it will never stop if you do not stop it. More clearly, suppose this is the negative and this is the positive, just feeding to this amplifier. From the output you will get, here is the positive, here is the negative, because it is 180 degree phase shift. So this terminal will be positive and this will be negative. As we are feeding back as a positive feedback loop, so the voltage from here, it will be added to the input. If you want to add it to the input, and this terminal, this end will be positive and this end will be negative. We do some mathematics based on this circuit configuration. So the total gain of this circuit is G equal to V out divided by V in. I mark this as equation 1. If we look at this circuit diagram, we can see that V in prime is equal to V in plus this ratio beta V out. So we can write it V in prime is equal to V in plus beta V out. We can rearrange this equation and find out V in equal to V in prime minus beta V out. The transistor gain by itself, AV is equal to V out divided by V in prime. So for the gain of this transistor by itself, we can write here transistor gain AV is equal to V out divided by V in prime, and from there I can write V out is equal to AV V in prime. Say this is number 3. So from equation 1, 2 and 3, from these 3 equations, finally we can get G is equal to AV V in prime V in prime minus beta V out, and then G is equal to, if I divide this equation by V in prime, then I can get AV divided by 1 minus beta V out divided by V in prime. We know that this term is equal to AV, so if we replace this one with AV, then we can get AV 1 minus beta AV. Now if we closely look at this equation, we can see that this is the fraction of this loop, positive loop, and it's the output voltage of the positive feedback loop. And if this is equal to 1, what is going to happen? The gain of the total circuit is infinite. Can you imagine what's going to happen if the gain is infinite of a circuit? For a little disturbance in the input of this amplifier, it will start oscillation by itself. That's why we can make an oscillation circuit using the amplifier, and the disturbance for this circuit in the input section by itself, it can happen by itself. Let's talk about this positive feedback loop circuit. How can we make 180-degree phase shift for a circuit just like this? Alright, we can use another common emitter amplifier with 180-degree phase shift, or we can use RC phase shift high pass filter circuit just like this. We know that this type of circuit, RC circuit, if the V in is here, you can get the V out with a phase shift of 60 degree. But the phase shift the phase angle of 60 degree, but the phase angle phi is dependent of the component's value, dependence on the component's value. So for one RC high pass filter circuit, we can get like 60 degree phase angle, and then like we need to add another two similar circuit to get total 180 degree phase shift. So here I have add two more high pass filter together, just like this. This is the input for this total high pass filter, and this is the output. One stage, two stage, and this three stage. So for one stage we can get like 60 degree phase shift, and from this stage we can get like 60 degree phase shift, and from this stage we can get another 60 degree phase shift. So that's how we can build up one positive feedback loop circuit for this amplifier, and we can make the oscillation circuit. We know that that's all components here for these positive feedback loop circuits are passive components. So that is why when the signal is coming to the input, it will lose the total peak to peak value of the input signal, and then finally that will give you one certain amount of signal loss to the output, and that signal loss or the attenuation for this three-stage RC filter circuit is equal to 29, or the gain for this RC positive feedback loop circuit is AB suppose 1, AB1 is equal to minus 1 divided by 29. What that mean? That means for this circuit it has like 29 of peak to peak voltage losses from input to output. So that's why this amplifier circuit must have to be the gain more than 29 or at least 29 to recover this signal losses for this positive feedback loop circuit. So now we can say the condition for oscillation, we have to get one 180 degree positive feedback loop circuit from the amplifier, and this amplifier has to have the gain of at least 29 volt per volt or more than 29 volt per volt. So that's two condition, and the feedback must be positive, not negative, otherwise that will kill the input signals. In my another previous video I have discussed about biasing a common emitter amplifier, how you can bias a common emitter amplifier, bias a transistor to make a common emitter amplifier. Now I'm going to talk about how we can make this whole circuit, and the complete circuit will look like this. First I'm making the common emitter amplifier circuit. That's the transistor. It's an NPN transistor. You can use 2N222 transistor or any other NPN transistor. So making the common emitter configuration first. It's RE, and this is the CE bypass capacitor, and this is RC positive power supply, and this is biasing resistor, the base of this transistor to the biasing resistor. Suppose this is R1, R2. So the feedback, positive feedback circuit I'm gonna add in this section. So how we can add this one? We have seen this is the positive feedback loop circuit. So this is the input for this loop circuit, this is the output. So I'm going to add this one, this input from the transistor collector, and this output will feed back to the base, just like this. So the capacitor and then resistor, and then another capacitor and then resistor, and then another capacitor, and then supposed to have one resistor here, but in this case I'm gonna using this resistor as a combination of this resistor plus the biasing resistor. So the biasing should be such a perfect biasing, otherwise this oscillation, the circuit will not give you the oscillation. So that is why you have to choose the right value for these components to get the oscillation. So for this circuit I'm gonna using here is 3.9 kilo ohms and 820 ohms, and for R is like 3.3 kilo ohms. All are is same. And for C I'm gonna using like 10 nanofarad, all 10 nanofarad. So all R is same, and then all C are same here. And for biasing the transistor I'm using here is like 68 kilo ohms resistor, and then R2 I'm gonna using here for like 12 kilo ohm resistor. So that's it. And then the output, final output, we can use 100 nanofarad capacitor to get the output. So, and this bypass capacitor, it just should be 4.7 microfarad to get the proper amplification. And if you put the 4.7 microfarad for this biasing transistor, you will get definitely more than 29 gain of this total amplifier. So let's see practically on the bench how this is working actually. And then without any input, any external input for this circuit will give you the sine wave oscillation. The frequency for the oscillation, total oscillation for this circuit, we can get from this equation. The frequency f is equal to 1 over 2s pi root over 2 n RC. The n is the number of stages, RC stages, like 1, 2, 3. So we are using like 3 stages, as we are using like 3 stages, 1 stage, 2 stage and 3 stage. So the value of n is equal to 3. So 2 times 3 is equal to 6. So the frequency we can determine from this equation, using this equation, 2s pi root 6 RC. So here is my circuit just placed on the board. So this transistor S8050, this is an NPN transistor. I have used before 1, 2 and 222 transistor, but just for now I'm using this transistor. So this is 4.7 microfarad and 820 ohms, 3.9 kilo ohms, and this positive feedback loop circuit here. The value of these resistors is each is like 3.3 kilo ohms, and this capacitor is 10 nanofarad, 10 nanofarad, 10 nanofarad, and this is the biasing resistor, and its value is 68 kilo ohms. It's just exactly as it is in this circuit. And then finally I'm getting this oscillation. Just here is my 9-volt power supply battery. That's 100 nanofarad capacitor, and from this capacitor I'm taking the output, and to see the output in the oscilloscope I just connect the channel 1, the probe. This is the channel 1 probe. I've just connected to the capacitor output, and here is the final output of the oscillation. You can see there is pretty much nice sine wave. And from the screen I can see like the peak to peak voltage is 4.9, and the frequency is 1.3 kilohertz. So that's how we can make the phase shift oscillation circuit. So if you like this video, please thumbs up, and don't forget to subscribe my channel, and that will be the inspiration for me to make some more qualityful videos. Thanks for watching, and see you next time.